Wait, sorry.
Yeah, no worries.
Here, I'll go
So
again.
whenever you're ready.
Hey, I'm Chiro. Hey, okay. Hey, I'm Chiro, and our other group members are Miguel, Milham, and Max. We're group 18, and we're doing ours over heart rate analyzation. So now basically we take a sample data sheet that we got from online, linked in our sources. It contains patient information like age, gender, resting heart rate, family history of disease, and a variety of other numerical and categorical values. Basically, we take heart disease and compare it to these other variables for statistical significance. So now for our flowchart, first we load the data. Um, you check for all the variables, and then for the for loop, you change the categorical values to items the script can read. You identify the variables, and then you save the data. At the end, for the p-test and graphs or the p-test, you're going to first, there's a for loop, and then it's two-sided. So for the numerical values, you're going to do Pearson correlation tests. And for the categorical values, you're going to do a NOVA one-way test. You're going to display the results, extract the variables and p-values, and then you're going to plot the p-values in a bar graph for easier readability. So then section 2, the chi-square test, you're going to do a chi-square analysis. First, you're going to set up tables, and then in a for loop, you're going to calculate those values for all the variables. You're going to store the data for each one. Section 3, displaying the chi-square values. So first, for a linear figure, you create the figure, you arrange the plots, basically where they're going to go spatial-wise, and you plot each chi-square test in the for loop. And then it saves the data to a file at the end.
This is Adila Edil Ali in short. For our Sandbox project, we use two main methods of statistical analysis, the components being ANOVA analysis and the chi-square test. First things first, ANOVA is an assessment technique, and it decides whether or not there are statistically significant differences among multiple groups. How it relates to our project is that we utilize this tool to determine the correlation between certain groups and heart disease probability. For further context, ANOVA provides a p-value, and that p-value is only considered significant if it is below the 0.05 threshold. Anything greater than that is considered insignificant. To our examination, and as I mentioned, we took advantage of this threshold to determine which variables were of statistical significance. When it comes to the other main component we use on the project, the chi-square test, it is an analysis tool that compares and checks any discrepancies between the data observed or given and the data we expect under certain circumstances. For our project, we analyzed categorical data and fed it to the chi-square test, which helped determine the chance that any relationship exists between the category and the heart disease, which all in all finally leads us to the results we reaped at the end.
So the results for this data analysis, we split them into two main parts, correlating to the two main parts of our script, which were the ANOVA analysis and the chi-square analysis. So for the ANOVA analysis, we included all of the variables, which was both numerical values like age and cholesterol level, as well as categorical values like whether they smoke or not. And so when we did a ANOVA analysis of all the variables, we analyzed their p-values, and based on the 0.05 threshold, we found that the only three statistically significant variables were age, cholesterol, and smoking, in that order of statistical significance. And for our chi-square test results, we also found p-values for all the values, but we only did categorical variables. And for these p-values, we also used the same 0.05 threshold to establish statistical significance. And we found that the only statistically significant variable in heart disease was smoking. So in conclusion, we found that age, smoking, and cholesterol level were the most statistically significant to heart disease and correlation to heart disease. So this is significant because this shows that these three factors should be the ones that are further studied in regard to heart disease and how heart disease could be prevented in the future. So that leads us to team contributions.
Our team contributions, as mentioned earlier, there are four of us. It is Curio, Max, myself, Miguel, and Mellon. Curio and Max worked on creating the flowchart, while me and Millum worked on organizing and structuring this presentation. We all had our contributions to the creation of the script, with some of us working more on the ANOVA part and others working on the chi-square analysis. For our future work, if we had more time for this analysis, we would love to integrate a feature where users would be able to input their own data and have it be analyzed in the same style. In theory, this should be so that they could add their factors like age, smoking habits, height, weight, or any other factors. We would also love to integrate better visualization into our results, like histograms, which would show distributions for numerical values and perhaps give us a better overall analysis of our data set. As for our references, we obtained our data from an experiment done on Kaggle, and this data was put onto an Excel spreadsheet. And we use this Excel spreadsheet to put in our code and be able to analyze. Here's the link to that same spreadsheet.